All right, kiddos. So tonight you're looking at tangent graphs. And again, we want to go back to that idea that everything comes from our unit circle, okay? So here's my unit circle drawn nicely. These would be my pi over 4s. This is starting at 0. This is my pi over 2. And we're going to graph a tangent graph this time. So instead of just looking at the x and y coordinates, we need to remember that on the unit circle, tangent theta was equal to the opposite over the adjacent, which actually ends up being the y over the x. Okay, so the y value over the x value. And the important thing here is to remember that we teach you the y over x as opposite over adjacent, when in fact, more importantly, we need to look at tangent theta is defined as sine theta over cosine theta. Okay, so I want to review two things real quick, and then I'll show you, because tangent theta is a little harder to graph. So the first thing that I want to remind you is that this right here, this is a ratio, and it's really a fraction. And we have one rule that all fractions have to follow, and that rule is that the denominator, in this case, cosine theta, cannot be 0. Okay, that's what's in the denominator. And in the fractional world, remember, anything over 0 blows up. As Miss Wynn would say, oh, noodles. So no noodles, can't have 0 in the denominator. So this can't happen. So if that happens, we need to remember that in Algebra 2, when the denominator were 0, example from Algebra 2, you had something like 1 over x minus 2. And hopefully we would all say, well, x cannot be 2, because that would make the fraction blow up and our world would cease to exist. Oh, noodles. So what that means is if x can't be 2, we would have a vertical asymptote at 2. And then we could graph this because we know we also have a horizontal asymptote at 0. And we could just choose points to the right and to the left, left and to the right of 2, and we could then graph that. So if I plugged in 3, 3 is over here. If I plug in 3, I get 1. And so something like this. And if I plug in 1, that's 1 minus 2, so I'm going to get a negative value. And so that's going to go something like this. I'm never going to really cross that asymptote, ever, ever, ever. Never. I'm going to get really, really close. But that idea, this is in our thinking bubble, that idea becomes really important, because if the denominator is equal to 0, then we have a vertical asymptote. So if the cosine of theta does equal 0, we have to worry about a vertical asymptote, okay? The vertical asymptote, something we cannot touch. And so what we want to do then is we want to go back to our unit circle. And remember, on our unit circle, on the unit circle, the cosine of theta was equal to the x coordinate. So where on our unit circle is the x value 0, the x coordinate? So looking around your circle, for example, this dot is at 1, 0. That's the y value. We're looking for the x coordinate of 0. If you do look around your unit circle, you will see that that happens in 2 places as we go around the loop 1 time. It's going to happen right here, and then as we come, it's going to happen right here. And those 2 values are going to be, for our parent function, we're going to hit those 2 values. Okay, that's going to be an issue for us. So that is the important component here. So what we want to do is say, okay, how are we going to find the period of our parent function? Well, the period, we're going to have some issues, right? Because we're going to go and we're going to run into pi over 2. Well, that's an asymptote, so we're not going to hit it. So let's start on the other side of pi over 2. And we're going to go, oh, so from pi over 2 to 3 pi over 2, I can see right there, from pi over 2 to 3 pi over 2. How far apart is that? From 3 pi over 2 to pi over 2, you get a period of pi. So for the parent function, who's your daddy? Parent function, we're going to end up with a period of pi. And just like with sine and cosine, for any one of those, we're going to find our period by taking pi and dividing it by b. Okay, we'll come back to the b. Now, what I would say to you is when we look at the endpoints, and again, remember, endpoints is in quotations because that is a very loosely used term. There are no ends, right? It goes on forever and ever and ever. But let's look back up here at our unit circle, and you can see that from pi over 2 to negative pi over 2 is 1 pi. And then I can go around the circle again. But every time I come back, I'm going to run into those discontinuous pieces right there. So it turns out that my endpoints, I want to do one cycle. And because we want everything like sine, when we graph that, we're looking from 0 to 2 pi for one period. When we do cosine, again, we're starting around 0. And because of the way the cosine and the sine functions look, we can do 0 to 2 pi. So we want our tangent theta, parent function, we want it to be near 0. Near 0. So that when we're graphing it, we have our frame of reference and our origin is in the picture. Remember, we said if we hit pi over 2, we're going to be at 0. And if we hit 3 pi over 2, we're going to be at 0. So I could do this. I'm never going to get there. Why am I never going to get there? Why am I never going to get there? And nuts. That should be a theta. Sorry, my bad. Theta. Because I said theta. Why are we never actually going to get to these two values? Why are we never going to get there? Well, let's go back up. That's our restricting factor right there. Cosine theta cannot be 0. And at pi over 2 and 3 pi over 2, it is 0. But that's not near 0. And remember, this is go on and on. So then the next one is a pi away, which is going to be at 5 pi over 2. And then again, it's going to be 7 pi over 2. And if it's true going counterclockwise around the unit circle, shouldn't it also be true going this way? So what's a pi away from pi over 2? If we go back and look at our circle, it's right here. Here's where we start, and we go backwards a pi, we end up here. So this is going to be for our parent function. For tangent theta, okay? If y is equal to tangent theta, and remember, this is just for one cycle, we're going to go from negative pi over 2 to pi over 2. And the reason we're doing that is simple. It keeps everybody's graphs looking consistent. There's really no other reason to do endpoints than to make them all look very similar so we can all see that we're doing the process correctly. Okay? So, recap, general information. Our function could look like this. And remember, your book will refer to this as the standard form. And we just want to remember that everything is still the same. A is still going to represent, only it's different. Well, we're going to call it amplitude for now, but you'll see that's fake for tangent. That's not true. B is going to help us find the period. We're going to do 2 pi over b. This is going to help us with period. H, what is it again? Tell me. Correct. That's going to be right or left shift. If you said horizontal, good job. I'll take horizontal. Okay, and then the last one is K. And remember, your book uses C and D. I don't like that. I like the H and K. So it looks a little different in terms of letters, but it's identical. And this represents my, if you said vertical, great. If you said up, down, great. Okay, so let's take a look now, and let's actually graph the parent function, y equals tangent x. Okay, so two things we want to do here. We want to say, okay, what's my amplitude? It's 1. What's my b? It's a 1. So the period is going to be equal to 2 pi over 1, which is going to give us 2 pi. this one right here is really, we use the word amplitude, but it really means how we're going to stretch it. We're going to stretch it either vertically, like make it long, taller or shorter, taller or shorter. And then what we want to do is we want to find one period. And one period is going to be from negative pi over 2 to pi over 2. Those are going to be the same no matter what. Those are going to be the same no matter what is in here. Okay? Notice we have no vertical shift and no horizontal shift. So that's good news. This is our parent function. So we're going to take this and we're going to pop it in here. Okay. So I'm going to go ahead and scroll down a little and I'm going to pull up a grid. So again, you just want to pull up some sort of coordinate plane. Okay. And then we want to mark off. And again, I'm not an artiste by any stretch of the imagination. So I'm not expecting you to be perfect either. All right. So here's my graph. And I can stretch this out a little, and hopefully that will help. Okay. And I'm going to label by pi over 4s. So pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. I could reduce those, but I don't want to. Negative pi over 4, 2 pi over 4s, negative 3 pi over 4s, and negative 4 pi over 4s. Okay, now we agreed earlier that if I hit pi over 2, it's going to blow up. My world ceases to exist. So I'm going to go ahead and 2 pi over 4s reduces to pi over 2, which means that negative 2 pi over 4s should also reduce to pi over 2, and it does. And here's how it works. If this is true, if this is going to happen every pi, I should be able to have it repeating over and over again. So every pi, I should have another one. Every pi, I should have another one. So I'm going to move this one out here, and we're going to pretend that it fits. Okay? So 1 pi is 4 pi over 4. So this is at negative 2 pi over 4. If I add 4 pi over 4 to that, or subtract 4 pi, I get negative 6 pi over 4. Okay? And I could do the same thing on the other side. If I put one over here, and again, I'm going to pretend that it fits, right? I'm going to pretend. I know it's not accurate, so bear with me. This would be at 6 pi over 4 right here. Okay? So what's going to end up happening is every single time we hit a cycle, we're going to have a complete graph. So in between each of these blue lines, we're going to have a complete tangent cycle. Okay, so in order to do this, before I just tell you, hey, here's the answer, I want you to come up and look at this function with me, because I want to do this. Y equals the tangent of x. Remember, that's the sine x over the cosine of x. Okay, so what I want to do is I want to look at the places where I have easy numbers. For example, if sine x and cosine x were equal, then this would be 1. So I'm looking, where is sine x equal to cosine x? On my unit circle, I'm looking for the x coordinate to be equal to the y coordinate. So look at your unit circle. It should be right there on your desk next to you, on the table, on the couch, doesn't matter. But look at that, and you should see that those values are exactly the same in 2 places. Now, in another 2 places, they're the same with opposite signs. And now it should become clear to you why I labeled my graph the way I did. At pi over 4, you should see square root of 2 over 2. Square root of 2 over 2. What's the square root of 2 over 2 divided by the square root of 2 over 2? You should get 1. So at pi over 4, I have a value of 1. Okay. Well, remember, I said I wanted to be centered about 0. So, hey, what's the sign of 0? 0 degrees. If I go to the dot that's on my unit circle at the sign of 0 degrees, it's 0. There it is. So what's 0 divided by anything? Hey, it's 0. Now, negative pi over 4. So let's go back here for just a sec, and I want to look at my unit circle, and I want to go backwards. So right here, this says root 2 over 2, comma negative root 2 over 2. So what's this? Negative root 2 over 2 divided by root 2 over 2. I come over here. So the sine of negative pi over 4 divided by the cosine of negative pi over 4. And I get negative root 2 over 2 divided by root 2 over 2. Correct? Which negative something divided by something is going to be a negative 1. So at pi over 4, I'm actually down here at negative 1. And that is not a straight line, although my graphing skills would imply that it is. But it looks something like that. And it turns out that because the period, which Miss Collins, oh my gosh, none of you checked me. Bad. Noodles. Noodles. Pi over b, which is pi over 1. The period for tangent is a pi length. It is a pi length. From pi over 2 to negative pi over 2 is for 1 cycle. Which means this 0 should happen every pi. So every 4 pi over 4, I should hit it again. Every 4 pi over 4, I should hit it again. Now, every 4 pi over 4, I should hit it again. So this should happen right here. This dot should happen right here. And it's going to repeat. And I am getting infinitely close to this asymptote without hitting it. I am getting infinitely close without hitting it. Okay? And that's going to repeat over and over and over again. So again, let us recap. Parent function, period. Pi over b. I hope that's the only place I made that error. Silly girl. Pi over b. Oh, good. Pi over b. Miss Collins, you're so smart. No, silly girl. I was writing it here. Okay, so anyways, done. Moving on. Okay, there's my parent function. All right, this is the piece that I want. Now I'm gonna box it. This is the piece that I'm going to be looking for right here. That's the piece I want to see. Okay, so we're going to be taking that parent function and we're going to shift it. So let's look at this. Now let's recall. Inside, that's going to do what? It's going to affect what? Say it. Period. Okay, it's going to affect our period. Our period is equal to pi over b. In this case, b is 2. So our total period length is pi over 2. Okay? That's from one asymptote to the next. So if I draw in a coordinate system, there's that. It should look in the center. And then I'm going to have 2 asymptotes. So from asymptote to asymptote, this distance is going to be a pi over 2 apart. Okay? I don't know where they are yet, but I know they're going to be pi over 2 apart. So now what I do is I say, okay, my multiplier, my stretch factor, my amplitude, and this is only for the first 2 dots after my 0. Okay, my amplitude is going to be at 1. And then I'm going to come down here, and I'm going to do 1 cycle. Is this the only possible cycle? No. But it's the one I want everybody to start with. So everybody's going to start with what should have been their parent endpoints. Inside here, I'm going to place what was here goes in here. This is from the parent. Parent, don't change it, Please do not change it. Please do not change it. Now divide by 2, divide by 2, divide by 2. I'm going to get negative pi over 4 to x to pi over 4. Okay, those become my endpoints. So it would appear to me that these are pretty equidistant from, close enough. So this is going to be at pi over 4 negative, and this is at pi over 4 positive. Okay, so cheat number 1. Now here's what I would say. I would say automatically, we want to go ahead and go, oh, we know one's going to be at 0, one's at 1, and one's at negative 1. That's really what we're going to do. Okay, that is really what we're going to do. And the reason I know that this is at 1 and this is at negative 1 is because my multiplier right here is a 1. 1 times 1 is 1. 1 times negative 1 is negative 1. And I want to make sure that this is mostly halfway. So what I would do is pi over 4 to 0. Half of pi over 4 is pi over 8. Negative pi over 8. And the only 3 dots that I'm going to have to label is 0, 0, negative pi over 8, negative 1, and pi over 8, comma 1. And it looks the same all the time. All right, a quarter of a pi and a quarter of a pi. Look at a quarter of a pi and a quarter of a pi. Half a pi. Okay, half a pi. Yes, I want you to leave your fractions. Don't need a calculator. Don't need decimals. Okay, 2 tan x. Okay, this 2 is outside. We called it amplitude. I called it the stretch factor. But that means my y values that used to be at 1 are now going to be at 2. Say it, 2. Okay, now they're at 2. Okay, is there any vertical or horizontal shift here? Anything? No, no, no. Okay, good. So let's just cheat. Now, we're not cheating. We recognize that we could make a data table. We don't want to make a data table. We want to know what's the shortcut. What does the picture generally look like? That's what we're concerned with. So remember, negative pi over 2 to pi over 2, parent function. And look, solve for x. Okay, well, what's the period? The period is equal to pi over, what is it? 1 pi. Okay, so let's draw in some vertical asymptotes. So here's one and here's one. And again, I could have another one out here and another one out here. I don't need you to do all of those. I just want to see one complete cycle. So one complete cycle for tangent goes here to here to here. Now, that's the basic pattern. I need to know what number to put here and what number to put here. I'm going to wait for someone to tell me. Miss Collins, it's 2, it's 2. Mr. Elmore, how did you get 2? Because you told me this is the stretch factor. Good answer. So 2, negative 2. And then I'm going to just go pop, 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 pop. Done. Now, the last step is to make sure I label the 3 points that I have to label. So remember, period, endpoints. Now, half of that, negative pi over 4, comma negative 2. Positive pi over 4, comma positive 2. Wow, 0, 0. Okay, and that would happen again and again and again and again. Okay, so let's do one more and then we'll call it a night. You'll be ready for tomorrow. What if I gave you negative tangent of x? What does this negative do to my graph? Think about that. I'm going to draw my coordinate system. You're thinking about that. I want you to either pause and think about it or be sketching your coordinate plane, yelling the answer out. Let's show your parents how awesome math time is. Okay, so I know it's a lot easier for me to draw here, so I'm a little faster. Okay, so in my head, I'm thinking aloud now. Well, There's no change to my x factor stuff, so that's pretty easy because Ms. Collins told me just to put this here all the time, every time. All right, well, this minus meant something for sine and cosine. Ah, that's right, that flips. Okay, well, what's the period? Oh, yeah, that's right. Ms. Collins told me the period is always pi over b, which is going to be pi because b is a 1. So that means my endpoints are going to be negative pi over 2 to pi over 2. And then Ms. Collins said, just go halfway and put in some dots and then connect the dots in a smooth curve like that. Okay, so I think I might be done, but it's red, so I'm clearly wrong because this minus sign means what was a negative value needs to become a positive value, and what was a positive value needs to become a negative value. And now I recognize that my curve goes like this. Okay? Again, we're changing the y values. This y value came up here. This y value came up here. Okay? Or vice versa. This y value came down here. Okay? So what was down goes up, and what was up goes down. So now when I label my points, it's negative pi over 4, comma 1, 0, comma 0, and pi over 4, comma negative 1. Okay? So tomorrow when you come in, you need to be able to do 3 things. Tell me what the stretch factor is, tell me what the period is, and tell me what those endpoints are. And when I say endpoints, they're not really ending. Remember, those are our vertical asymptotes. So 3 things for tomorrow. You need to tell me what is the stretch factor and how can I find it. Okay? What is it and how can I find it? You need to tell me what the period of a tangent function is. What is it and how can I find it? And the third thing that you need to be able to tell me is where are those, remember, endpoints loosely. In this case, we're looking for those vertical asymptotes that will end one cycle of my graph. Okay? Tell me, where are my vertical asymptotes and how can I find them? 3 things. All right. Good luck.